space up, go Falcon, go NASA.
Constellation, giving accurate navigation to billions of us around the world. Stay with us as we follow this landmark mission. Over in Mission Control, the team's on console in the fishbowl behind that protective glass. And we are actually in our commentary box looking down over those operational teams. I'm Katie Haswell, and joining me is our rocket expert from Arianespace, David Iranzo-Gross. Thank you very much indeed, David, for being with us.
Thank you. Great to be here.
David, how's everything going?
So far, so good. The teams are preparing the launcher and the ground facilities for this launch. Everyone is getting ready for this very important launch for us and for Europe.
Absolutely. A very, very important launch today. And we've got quite a long journey ahead. It's going to take about 4.5 hours to deliver and check the health of our satellites. David and I are going to be with you the whole time. We'll, of course, be discovering our satellites. We'll be finding out more about operations across the range. We'll be seeing the Mission Control Center and obviously looking here at the other control center, David?
Yes, the Launch Control Center, the CDL3, where the teams are closer to the pad, and these are the teams responsible for the operations on the rocket and the launch pad.
We'll also be meeting the teams at the Quick Look Telemetry Center, which is just outside the spaceport, and they will be taking on the baton, if you like, after launch, monitoring all the events on board our rocket. So let's go back inside Mission Control now to the fishbowl, and Caroline Arnaud, who is the Ariane Business Unit head at Arianespace. Caroline, thank you so much for coming to chat with us.
Good evening, Katie.
How are things looking for launch, Caroline?
Yes, boards are green, all systems are nominal, the teams are ready, fully focused on the chronology. So the operations are running smoothly, so everything is fully on track, and we look forward to a beautiful launch tonight.
And tell us more about our passengers on board Ariane 6 tonight.
So on board tonight we have two Galileo satellites, SAT-33 and SAT-34. They are part of the 14th operational launch in Galileo program. Galileo is Europe's own global navigation satellite system. It is the world's most precise positioning system, and it currently provides services to 4.5 billion of users all over the world.
That's a lot of users. And as I said earlier, Caroline, it's a thoroughly European launch, isn't it?
Yes, by launching tonight two Galileo satellites for our key partners, ESA, European Commission and USPA, we are reinforcing Europe's own navigation system and also Europe's independent access to space, which is a key commitment for Arianespace.
And it's also a very important launch for Ariane 6, Europe's rocket.
Yes, Ariane 6 is off to an incredible start with 4 successful launches and the launcher available today on the launch pad. In less than 18 months, it is the fastest ramp-up ever for a heavy lift launcher.
Well, that's very, very impressive. Caroline, thank you so much.
Thank you.
And best of wishes to you and the teams. Thank you, Caroline. So we are scheduled to lift off in just under 21 minutes, David. What's going to happen after that?
So tonight Ariane 6 will lift off towards the northeast, targeting a 54-degree inclination orbit. It will be powered by its main cryogenic engine and the 2 solid propellant boosters. These boosters will be separated 2 minutes and 15 seconds after launch, followed a bit over 1 minute later by the fairing separation once the launcher has left the Earth's atmosphere. The launcher will then continue its ascent up to 7 minutes and 39 seconds when the main stage will have finished its job, and the onboard computer will command the shutdown of the Vulcan engine and the separation of the main stage. A few seconds later, the Vinci upper stage engine will be ignited for the first time, and it will burn for about 11 minutes, putting the launcher in a transfer orbit towards a medium Earth orbit. We will then have a long coasting phase, around 3 hours and 20 minutes, going up to 23,000 kilometers. And once we have reached this altitude, the upper stage will be reignited for almost 2 minutes, injecting the satellites into their final circular orbit, where they will be separated. The satellites will then start their autonomous operations, and the upper stage in parallel will be passivated.
So lots to come. And once they're on their orbit, it's going to take a few months for the satellites to be commissioned and readied to start their job. And it's an important job. Every time you order a pizza delivery, book a ride on a taxi app, or transfer money with your online banking, you are using global navigation systems. I think we don't always realise quite how important satellites are in making our everyday lives run smoothly. We've all got a little bit used to navigation, I think, in recent years. But Galileo is Europe's own satellite navigation system, and with more than 30 satellites in orbit, it provides highly accurate positioning, navigation and timing services to billions of us, as Caroline was saying.
Yes, it is reliable and precise, and very importantly, it is independent. So Galileo strengthens Europe's autonomy in space. Today, satellites 33 and 34 are scheduled to join the constellation to ensure the continuity of the service and to improve the robustness of Galileo by adding spares to guarantee that it can provide navigation services 24/7.
And today is the 14th time that batches of Galileo satellites will have launched into space, but it's the first time that they'll be riding on board Ariane 6, and she's going to take them all the way to just under 23,000 kilometres above our Earth. Let's find out more about them.
Tonight, from Kourou, the European Union is launching a new pair of satellites as part of its most ambitious space program, Galileo, the EU's own global navigation satellite system. With each new satellite, Galileo grows more robust and more independent. This launch marks the 14th operational mission of this inspiring program, known as Galileo Launch 14. Galileo is invisible, but its impact is everywhere. It is the world's most precise navigation system, serving over 4.5 billion smartphone users around the globe since it became operational in 2016. Whether you are checking a map, making a digital payment, synchronizing a network, or calling for help, Galileo, in the background, keeps your daily life running smoothly. At sea, Galileo satellites keep vessels on safe routes. In the fields, it guides tractors with centimeter-level precision. On the ground, it supports emergency services. For everyone, every day, Galileo turns a vague location dot into a position you can trust. Behind that reliability lies an architecture built for performance. Galileo is operated by the EU Agency for the Space Programme, EUSPA, and managed by the European Commission. Since its inception, the European Space Agency has been leading the design, development and qualification of the space and ground systems, as well as producing and carrying out launches. Galileo full operational capability satellites carry ultra-precise atomic clocks. This timing precision is the foundation of the system. From it, your receiver can determine position with centimeter-level accuracy. This new duo also broadcasts multiple frequencies at the same time, boosting resilience against interference. Aboard Ariane 6, Galileo satellites 33 and 34 will join in about 3 months, a constellation orbiting more than 23,000 kilometers above Earth. Each spacecraft is a small piece of a larger ambition, that Europe continues to maintain an independent navigation system designed for global users who rely on stability, accuracy, and trust. In a world shaped by instant communication, navigation is a pillar of our daily life, our society, economy, and safety. And that is why this mission matters. Each Galileo satellite added strengthens a system that supports modern life in ways we rarely see, but constantly depend on. Galileo continues to grow, quietly building a future in which Europe navigates with confidence.
And today we're launching the 2 first-generation satellites, but the next generation is soon to follow, isn't it?
Yes, after tonight there will be 2 additional Ariane 6 launches with Galileo first-generation satellites, which are built by OHB in Germany. And the second-generation Galileo satellites is now in preparation. Satellites are being designed and manufactured by Airbus Defence and Space and Thales Alenia Space. And these new and more powerful satellites will be launched 2 at a time, stacked on top of Ariane 6.
14 minutes to launch. Back in mission control, all the status panels are green. And do you want to talk us through what the systems are? We're looking here at the teams here in the mission in the fishbowl.
These are the ESA teams following the satellite.
The status panels, David, we are looking at 3 different systems, aren't we? Oh, and actually, quickly, just let everybody know, this is the flight desk.
Yes, here we have the management teams of Arianespace and Ariane Group that are following the launch.
So talk us through the status panels.
So yes, we have 3 main systems across the base, the launcher with its ground systems. what appears as Ensemble des Lancements Lanceurs. We have the satellites, of course, the Galileo satellites, and a third group, which is the range, which includes the telemetry, radars, weather, and safety systems that are needed for the launch.
And all of those need to be green, of course, for a launch to go ahead. So we were mentioning earlier we have another control centre, launch control, very close to the pad. What are the teams in here doing, David?
Yeah, the Launch Control Center, or CDL-3 as we call it, it's a concrete bunker that's 5 kilometers from the launch pad. And these are the operations teams. They are sending the commands to the launcher and to the launch pad systems, turning the launcher avionics on, filling the propellants in the tanks, pressurizing the tanks and opening valves, doing all the planned checks that we need to do before we go for launch. And also, right next to them, we have the engineering teams who are closely monitoring all these operations. They are making sure that all the parameters, here they are, that all the parameters are in the specified ranges in terms of temperature, pressures, electrical currents. And they also have the support of teams back in Europe who are there to help in case of need.
Very important that as many people as possible on the job, and of course teams in Europe seeing a mirror of that data coming in. The final weather check's coming up in about 1.5 minutes. Obviously the weather's important. All the conditions must be right for a launch to go ahead. And the European spaceport is on the Amazonian coast of French Guiana in South America, so we do get a lot of rain. And actually, it has been the beginning, really, of the raining season recently, hasn't it?
Yes, we've had some rain these past few days, but yes, rain is not the problem. We need to monitor a couple other things. One of them is the high-altitude winds, between 10 and 20 kilometers. We need to make sure that wind speed and direction are within a certain limit in case of problem during the launch. And also, we need to monitor the lightning risk. During the ascent, we need to avoid any lightning on the launcher. On the ground, we have the lightning masts that protect the launcher.
And we have a weather station here at the spaceport. How do they actually monitor the weather? What do they use?
So there are predictions that are made, very accurate predictions, and they use, for example, the balloons that we see here, which carry sensors into the upper atmosphere, sensors that measure temperature, pressure, humidity, and these elements are taken into account in the prediction models to have accurate wind predictions and lightning predictions.
And the boards have remained green. The weather status panel is green, so that's a good sign. That means that we are go for launch when it comes to the weather. Teams have been working here at the base now for some time preparing. What have they been doing, David?
So the elements of the launcher arrived on the canopy boat that you see here, a new hybrid boat using sails for its propulsion. The elements of the launcher arrived in August. They were transported to the spaceport by road to the horizontal assembly building, where we have the assembly of the main and the upper stage. Horizontally, the mechanical mating, and then the checks, electrical checks. Once this is done, the whole central core is transported to the launch pad, which is 800 meters away, using these automated vehicles. Once the core is on the launch pad, it is put in vertical position, and then it is hoisted and put on top of the launch table. Once this is done, the boosters come to the launch pad as well, and everything is assembled together. On the passenger side, the Galileo passengers arrived in French Guiana on November 6th, just over 1 month ago. They were prepared during 4 weeks. They were fueled, checked, and then they were integrated around the dispenser, which is the golden structure that you see here. So the two satellites were attached on it, and then they were transported to the encapsulation building where the satellites and the dispenser were integrated on top of the launch vehicle adapter that you see here, and then the fairing was put around it. And once this was done, the whole structure was ready to go to the launch pad. So it was transported there just a few days ago, and then it was put on top of the launcher where the final connections were made and the final checks were made in preparation for the launch today.
And now here we are, 7 minutes and 32 seconds to launch. But the final countdown actually started over 8 hours ago, and there have been lots of different operations during that time. Do you want to run us through some of the highlights?
Yes, the countdown started, in fact, even 11 hours ago, but the main event was the removal of the mobile gantry, which happened 8.5 hours before the launch. After that, the propellant lines were flushed to get rid of any leftover humidity, and then the lines were cooled, and the start of the fueling of the tanks began at that point 5.5 hours ago, 5.5 hours before launch. And in parallel, there have been electrical checks, armings of the pyrotechnic systems, and we on the launch base site, we had the telemetry and radars being ready for launch. So now we are in a stable situation, and we are waiting for the start of the synchronized sequence, which will take place in a bit over 1 minute.
Nice shot there of the whole pad. We can see the lightning towers that you mentioned there, David. Just describe what we're looking at. We've also got some fire down at the bottom right. That's perfectly normal.
Yes, that's right. That's what we call the hydrogen pool, where the excess hydrogen is being burned. But yes, as you say, that is totally normal.
And we can also, you can't really see them very well, but at the bottom of the right and left of your screen back there, you could actually see what we call the calno, which are the exhaust, big blocks of concrete where the exhaust will come out. Getting close now to the 1 minute mark. Everybody looking at these screens here in the Mission Control Center. The Range Operations Manager today is Raymond Boyce, and he's going to be calling out all the major milestones during the launch. And it's Jean-Frédéric Alazin. In fact, I made a bit of a mistake there. My apologies, Jean-Frédéric. So he's in charge of coordinating the launch-based systems during the final countdown. And as I said, he'll be calling out all the major milestones.
And yes, we have had the start of the synchronized sequence,
which is the last final 5 minutes in the countdown. Lots of operations during this time.
Yes, lots of operations, very precisely timed, combining the last checks, the last pressurization of the tanks, the activation of the different systems, and opening of the valves on the launcher. And the control of the operations is gradually being handed over from the ground systems to the onboard computer, and it will be actually the launcher onboard computer who will decide on the start of the main engine, and who will then send the command to the boosters for ignition.
So we're getting close now, concentration levels high. We're looking there, we can see a good shot of the Vulcan engine on the main stage of the rocket. Now let's just run through a few things to watch out for. That Vulcan engine, David, is going to switch on 7 minutes, isn't it? 7 seconds before launch.
Yes, that's right. There will be the ignition of the main engine, and then there will be checks that will be performed, making sure that it is running as expected. And once this is done, then the command will be sent for the ignition of the boosters. And once this happens, there is no holding back. 400 milliseconds after that, the launcher will lift off.
Only 400 milliseconds between ignition, between the command and the
actual liftoff.
Actual liftoff. Very quick. If you look at the top of the rocket, can you see those yellow sections on the right and left? Those are actually the cryogenic arms clamping onto the top third, onto the upper stage of the rocket, feeding very, very cold propellants into our rocket.
Yes, they're feeding cryogenic oxygen and hydrogen. As you say, they are very cold, and so they are continuously evaporating, and therefore we need to continuously fill in the tanks up to 3 minutes before the launch. So we just stopped a few seconds ago, and these arms will retract just a few milliseconds before the actual liftoff.
And sometimes you can see, depending on the camera angle, you can see a little bit of white smoke, what looks like white smoke, coming out of the top of the rocket. It's not actually smoke, is it? It's
it's condensation of the humidity in the atmosphere here in Kourou, which is very high.
We'll also see the umbilical lines retracting and pulling away at liftoff.
Yes, that's right. The umbilical lines, which carry electrical power and ventilation to the launcher and to the satellites. And this will be automatically disconnected as the launcher moves up.
1.5 minutes to launch now, getting close. Nice shot there of the Vulcan engine on the main stage. Just a reminder that that's going to switch on 7 seconds before the boosters. And once the boosters ignite, we lift off. We have a 15
À tous de DDO. Attention pour moins 1 minute.
Irreversible sequence at minus 15 seconds.
Top H0 moins 1 minute.
We are 1 minute to launch. Best wishes to all the teams and to the Galileo satellites 33 and 34 as they get ready to start their journey. Good luck, everyone.
À tous de DDO. Attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage des ESR et décollage. Début du basculement. Les paramètres à bord sont normaux. Trajectoire nominale, les paramètres à bord sont normaux.
And we are off. Satellites 33 and 34 in Europe's satellite navigation constellation have started their journey on board the continent's Ariane 6 rocket. Galileo satellites are on their way. We are supersonic. We've broken the speed barrier. The range operations manager is telling us that everything is going according to plan. And we are hearing the rumble of the rocket as it flies over our mission control center about 16 kilometers away from the pad. It's taken over a minute, about a minute and a half for that sound to come to us. Right-hand side of your screen, we're looking at the telemetry information coming in from our rocket. David, that's the curve on the top right-hand side?
That's right, yes. So the green line is the prediction and the yellow line is the actual position of the launcher. So we see that we are right on the spot.
And below that, our altitude. And we're presently 43 kilometers and climbing above Earth. Our distance from the pad, if you were to draw a straight line, and our speed. Right, our boosters are doing all the work, David, aren't they?
Yes, that's right. About 85% of the thrust needed, and they will be separating in just a few seconds at 63 kilometers altitude.
Trajectoire nominale. Séparation ESR.
And we have confirmation there from our range operations manager that those boosters have been separated as planned. So, we are losing weight. As you say, that's the name of the game, to jettison as much mass as possible as we go through the flight. And we're burning 3 engines, as we said. We switched on the Vulcan 2.1 on the ground on the main engine and the boosters. But as we said, the boosters really were doing all the work. Now, we don't need them anymore. The fairing at the top of the rocket is where our satellites are housed at the present time. That will be the next thing to be jettisoned. What's it protecting us from?
So the fairing protects the satellite on the ground from dust and humidity, and then during the launch from the acoustic vibrations of the launch, and also, of course, from the friction and the heat during the ascent through the dense parts of the atmosphere. And it will be separated once we don't need it, meaning at around 110 kilometers, so very soon.
There we go, that's how it looks.
Séparation des coiffes, trajectoire nominale.
Confirmed by the range operations manager, who's also telling us that the trajectory is normal. And you can see there our altitude, 116 kilometers now above Earth. So we've crossed what we call the Kármán line, if you like, the border with space. And we can see our satellites for the very first time, David, and they can see space.
Yes, that's right. The image shows the launcher with the satellites and the dispenser on top of the launch vehicle adapter, the black cone on top of the launcher. This is the simulation. These images are a simulation based on the outputs of the trajectory calculations, showing the launcher as it should be right at this moment.
Indeed, the simulation is very much a very useful thing for us to be able to see. We call it the 3D or the CGI images, and they use the gaming software Unreal Engine to create those images. So, as we said, our trajectory on the right-hand side, and below that you can just see actually the people there in the Launch Control Center, David, now watching the launch.
That's right. Their job is finished, but they are, of course, following the launch very closely.
So, we are burning the main engine. It's a great big tank of fuel. You can see it there.
Yes, it's 32 meter high, 5.4 meter diameter, and it's full with 154 tons of liquid oxygen and liquid hydrogen. The chemistry of these two elements leads to one of the most fuel-efficient combinations that exist for rocket propulsion, meaning that for a given amount of propellant, we will get the highest acceleration transferred to the launcher and to the satellites.
He's telling us that we've got 2 minutes left on the burn on the Vulcan engine. And it is indeed a powerful engine, isn't it, the Vulcan 2.1?
Yes, it's 135 tons of thrust in vacuum, and it burns the propellants in around 7.5 minutes, increasing the speed and the altitude. Today, we will go up to 5 kilometers per second with this stage, and up to an altitude of 200 kilometers. And this engine actually has been optimized with respect to Ariane 5. The nozzle manufacturing has been optimized. There are some additive manufacturing elements that have been added, like the gas generator. And also we have added a thermal protection on the nozzle that we saw before on the launch pad to protect it from the heat from the boosters during the launch.
So you can see our altitude, 169 kilometers, so we're increasing our altitude and increasing our speed. At the moment we're 3.4 kilometers actually per second. And actually, we not only are we travelling fast and getting higher, but we're actually rotating, aren't we, very slowly?
Yes, that's right. There is a small rotation that is done in order to keep the heat on all parts of the launcher at the same rate.
Pas d'écart en altitude, la trajectoire se poursuit nominalement.
He's telling us everything's going well. David, is quite interesting actually, because we launched, didn't we, 2 Galileo satellites from the Guiana Space Center exactly 10 years ago today.
Yes, that's right. On this 17 December 2015, there was the launch of launch 6 of Galileo with satellites 8 and 9 that were launched, yes, exactly 10 years ago.
Les paramètres à bord sont normaux.
So everything's going well, coming up to the next main event, and that is the switching off of the
Séparation
main engine.
LLPM.
And we have confirmation
Fin de mission sauvegarde.
that main stage has now been separated and jettisoned.
Allumage Vinci.
And the Vinci upper stage engine
Propulsion
has
nominale.
now switched on and the propulsion is normal. And we are being tracked now by the naval tracking station. It's actually on a boat, isn't it?
Yes, that's right. For today's mission, flying northeast across the Atlantic, there is no tracking station on the ground that can see this part of the trajectory. Therefore, we use a mobile tracking station that is installed on a boat, and we position the boat in the right place in the middle of the ocean to be able to follow the launch.
So the upper stage is very much now in charge. It has a super important job to deliver its passengers to their required dropping off point, if you like, in space, their required injection point, and that is a very specific and precise place. We've got a new engine for the Ariane 6 upper stage. It's called Vinci, as I mentioned earlier, and it's a very sophisticated piece of kit.
Yes, the Vinci engine and the upper stage is one of the big innovations of Ariane 6, which provide mission flexibility. It is designed, they are designed to be switched on and off up to 4 times, which allows to take different satellites to different orbits, but also to go to high circular orbits, like it's the case today, to MEO or even to direct geostationary orbit. And for this mission today, we will use the engine twice to deliver the Galileo satellites to their destination.
And the company which builds the rockets is Ariane Group. And with the support of ESA, they're developing a new stage for Ariane 6. Wow, that looks very exciting.
Yes, Astris will give Arianespace the capacity to perform even more complex missions on Ariane 6.
Even more flexibility, so that's really good. 13,000 or so people across Europe are involved in creating Ariane 6. That's what you call teamwork. One of those companies makes the pyrotechnics for separating the sections. They're called Pyro Alliance.
Pyro Alliance is a subsidiary of Ariane Group, which designs and manufactures pyrotechnic equipment for space, aeronautics and defense. We've been supplying the Ariane family for several decades now, with more than 100 kilometers of pyrotechnic cords delivered and thousands of equipments that have operated with a 100% success rate. We are close to 300 collaborators dispatched on 2 sites, in Les Mureaux and in Toulon, both contributing to the Ariane 6 pyrotechnic chains. The principle of a pyrotechnic chain is simple. The chain performs a signal transmission along pyrotechnic lines which carry the energy necessary to trigger the terminal functions. We contribute to many terminal functions on Ariane 6, which are all mission critical. The ignition of the solid rocket motors, the separation of the boosters, the ignition of the retro rockets, the separation of stages, and finally the flight termination system, which is a mandatory safety function securing the rocket destruction in case of hazard during the flight. The benefits of using pyrotechnics are the very short actuation time and a very robust technology which is immune to the extremely harsh environments that the launcher has to face. The challenge when you develop such products is that you have to prove a reliability of 1 in a million on products which are one-shot and cannot be tested before flight. For Ariane 6 we have in particular developed a brand new family of lead-free products, linear shaped charges, detonating cords and transmission lines. Last but not least, based on the customer's choice for each launch, we also offer hold and release mechanisms for the dispensing of the payloads. Pyro Alliance and all its employees are very proud of contributing to Ariane 6, the launcher that will durably secure the European access to space, and we are fully committed to perform a successful ramp-up for the program.
Pyro Alliance doing some really important work there. And during that film, we locked onto the signal at the Santa Maria tracking station. That's in the Azores. The 9 volcanic islands, actually, in the Atlantic, isn't it? So our flight path, David, takes us northeast, you were saying?
Yes, we are going northeast over the Atlantic, in fact very close to the airplane route that flies from Paris to French Guiana. And we will soon be flying over Europe and then down through Central Asia and Australia.
And the rocket talks to us. It sends us a signal to the tracking stations as it flies over, and they then collect data about how things are going on board, and they relay those data to the Quick Look telemetry team.
Yes, the CVI team, they are collecting real-time data, which the launcher is sending through the different tracking stations, and this data includes the status of the engine, the trajectory, and the flight control. And they are comparing this live data from the rocket to what has been predicted. And this allows them to continuously analyze the behavior of the launcher and confirm that everything is going as expected. This is the information we are getting regularly. And of course, they will also be able to confirm once the satellites have been separated in their final orbit.
And the range operations manager is listening in on their comms loop. And once they've confirmed major events, he's then able to call those confirmations out to the rest of us here at the base. Let's take a quick look again at our telemetry information coming in on the right-hand side, David. We're travelling fast.
Yes, we are now close to 9 kilometers per second and with an altitude of 150 kilometers.
And the range operations manager is telling us that everything is going normally and according to plan. Now we we're travelling faster and faster and faster. We need to be climbing higher, don't we, later in the flight and really climbing up into space. We've got a long way to go. We've got to go quite high today.
Yes, that's right. We will be climbing. We will be picking up speed and then climbing up to a high orbit, close to 23,000 kilometers.
And we're looking here at the satellites attached to their dispenser. That's the gold structure in the middle there between the two satellites.
Yes, that's right. It's it's a composite structure. It's a dispenser similar to the one that was previously used for Galileo launches on Ariane 5 and on Soyuz. And it has been, of course, adapted to Ariane 6. And this structure includes the hold and release mechanisms that keep the satellites attached during the ascent, and that will gently separate the satellites once they reach their final destination.
We are now at an altitude of 165 kilometers and climbing. We've travelled quite a distance, 5,222 kilometers across. If we were to fly across our planet, that's the distance that we've flown, and we're now, heading up to 9.62 kilometers there per second in speed, which is something above, I think, 28,000 kilometers an hour. So we are going fast, and we've had confirmation there.
We are coming up with
I thought I heard confirmation of the extinction of the Vinci upper stage. And that's how it looks up there.
Okay.
And he's also telling us that the APU is functioning normally. And the first major step, therefore, has been accomplished in reaching the desired orbit. We're now coasting without our engine. Why do we switch it off now, David?
Well, we have reached the necessary velocity, and Ariane 6 is on an elliptical orbit around the Earth now. At its closest point, what we call the perigee, the rocket is about 150 kilometers above the Earth. And at its farthest point, what we call the apogee, we will reach close to 23,000 kilometers, the altitude of the Galileo constellation.
Indeed. And I do believe that we are flying and heading towards Europe there. I can see the UK, and I can actually see the lights of London emerging. I can just see the sort of west coast there of the UK, Wales, and beautiful Devon and Cornwall. That's my home country, so it's nice to fly over and say hello to everybody in the UK. Let's turn our attention now to our satellites. He's telling us that everything is functioning completely normally. Now, the European Space Agency is responsible for carrying out the Galileo launch, along with Arianespace, and as Galileo's prime and design authority, ESA has guided the program from its earliest days. I am delighted to be joined by Javier Benedicto, who is the Director of Navigation at the European Space Agency. Javier, thank you so much for coming up to the commentary box to talk to us. Yes, indeed. Good morning. With satellites 33 and 34 now joining the fleet, how does Galileo strengthen Europe's autonomy and resilience in navigation and timing services? Before you answer the question, I'm just going to mention that I think I've heard the range operation say something about the station, but anyway. Yes, so tell us all about that.
Well, Galileo has become an essential piece of infrastructure.
Start again, please, Javier, because your microphone wasn't...
Thank you, yes. Galileo has become an essential piece of infrastructure for Europe. It is serving billions of users worldwide, and it is serving our society, economy, but also our safety and critical applications. So Galileo has to work all the time. We have to improve the performance and improve the robustness, and this is exactly what these two satellites are going to provide. So we have a responsibility to actually make the system perform better and better, and to make it work at all times, even if we have any sort of anomalies in orbit of the satellites which are already serving the constellation. With these 2 satellites, we're providing for additional redundancy and the necessary resilience for all the applications that Europe wants to provide through Galileo.
And looking ahead, what's next for the constellation?
We still have 4 satellites of the first generation, which we're going to launch in 2026 and early 27, and we are producing at the time 12 satellites of the second generation, which are going to provide for additional power, more power on ground, which is very important for a variety of applications, but also a lot of flexibility in order to reconfigure the satellites while being in orbit, because they last 15 years, 12 to 15 years, and the market changes all the time, so we need to be able to reprogram our satellites in order to match the needs of the users.
That's very important, isn't it? And I mean, what about just taking the next step now and looking slightly further into the distance in the long term? I mean, what are ESA's plans for continuing the competitiveness?
We need to continue improving our technology because as the market is developing, the needs are becoming more and more demanding. So we have to improve performance, obviously, but in particular improve the robustness of the system. And for that, we are going to test in the coming years new technologies. We want to equip our Galileo system with optical intersatellite links, which will provide for increased means of accuracy and robustness of the services on ground. We will in future make use of also quantum technologies, and we are going to launch very soon the first European satellites for navigation in low Earth orbit. A program we call Celeste in European Space Agency, and which will hopefully set the grounds for a new layer, a new segment to augment Galileo in the future.
Gosh, there's a lot going on. You're going to be very busy, aren't you? Listen, thank you very much indeed, Javier, for coming and telling us all about that, and best wishes now to you and all the teams for the next phase. We are now climbing high to our orbit. It's going to take us about 3 hours to get there. We've got to climb up to just under 23,000 kilometers above our planet. So we're going to take a little break. We're going to come back to you at 8:35 Universal Time, which is 9:35 in the morning in Europe, and at 5:35 here in Kourou. So we will see you back here then.
Go Falcon, go NASA.